Okay, this is a problem using vector forms, a fairly abstract one. So I chose one pen then. But like all diagrams, it's all forces and mechanics ones. It's best to draw the particle and our object. So we've got a particle P. It's got force 1, which is 4 minus 5. So we're going to do something like that. So F1, which is 4 minus 5 newtons. And we've got F2, which is 2, 1. So it's going to be something like that. And the question is, what's the acceleration in component form and as a scalar? Well, the first thing we need is we're going to get the resulting force by completing the parallelogram, by adding the two forces together. And that gives me Fr. I'm changing colour to show this is the resulting force. So the resulting force, Fr, is the vector sum of F1, F2. So we add those together, so F1 is 4 minus 5, and F2 is 2 and 1. So we get a resulting force of 6 minus 4. We then have, and that's a force in newtons, then we're asked to find the acceleration. Well, we've got basic F equals ma. The resulting force is the mass times its acceleration. So we've got 6 minus 4 newtons is equal to the mass, which was 4 kilograms, times our acceleration, which I'm going to call AI and AJ. Divide through by both sides by 4, and we get AI, AJ is 1.5 and minus 1. And that's meters per second squared. That's part A. Part B is the scalar for the vector A. So that's do Pythagoras theorem. 1.5 squared plus minus 1 all squared gives me a result. Square root of 3.25, which is 1.80. Remember, 3 significant figures for suitable accuracy. That's my acceleration. And I'm going to do a second question where we know the final motion of a particle, but where the we need to work out one of the new forces needed. So if we've got two forces, P1 and P2, they work together to accelerate a particle in the direction 5i, 5j. We need to find what P1 and P2 both are. So the way I'd approach this, first of all, let's just do a quick sketch of the diagram. We've got a particle, and its resulting acceleration is 5i, 5j, and that's the acceleration. Use that to create a force, and then we don't need to worry about accelerations again. So the resulting force is the mass times the acceleration. So it's 2 times my vector 5, 5. So it's equal to 10 newtons. We've got applied to that two forces, one which is 6i, the first newton, P1 is 6 minus 1, and we've got a second one that probably is doing something like that, but the maths should tell us in the end, the second vector, P2. Well, the P1 plus P2 equals Fr. So we can do our vector sum. IJs are perfectly valid, so are column vectors. So Fr is 10, 10, and is equal to P1, which is 6 minus 1, plus some vector xy. So the resulting then part of this is if I subtract that, it means P2 is equal to the vector 10 minus 6, 4, 10 minus 1 is 11. And that's the vector required to balance this function to lead to the acceleration. So actually in my diagram, I was slightly wrong. It probably should really come round to the end. You don't know that until you've solved the problem. So this is perfectly okay as a diagram, but in reality, we know this comes round and P2 actually works in that direction. All right, so they're basic vector and forces questions.